Introduction of sets. Set is a collection or group of well-defined objects or things that follow a certain common rule. For example, set of human presidents in the Philippines, a set of consonants in the word algebra, and a set of counting numbers less than 2. Examples of non-set: a set of books, a set of students, a set of good athletes, a set of difficult subjects, a set of low things in class. How to name a set. Capital letters of the English alphabet are usually used to denote a set, like A, B, C until Z, or set A, set B, set C until set Z. The letters used as elements of sets are usually written in lowercase. Next type, Alex, subtype is an element. Each member object is called an element of that set which it belongs to, represented with a symbol E, and is read as belongs to or is an element of is the member of. For example, set X has an element of 2, 3, 4. In symbol, 2 is an element of X, 3 is an element of X, and 4 is an element of X. Another example, Y is a set of string instruments. Thus, the element of set Y are guitar, violin, ukulele, and harp. In symbol, guitar is an element of Y, violin is an element of Y, ukulele is an element of Y, and harp is an element of Y. Now let's proceed to the cardinality of a set. It is denoted by the symbol n negative A, which means the number of elements in a set. Example, set A has an elements of N, O, R, M, A, and L. Thus, N, or the cardinality of a set, has 6. Now, let's proceed to methods in writing a set. First method is Alistre method. In this method, each element of a set is listed and enclosed in a pair of braces. For example, W is a set of counting numbers between 1 and 5. By Alistre method, W has an element of 2, 3, and 4. X is a set of string instruments. By Alistre method, X is an element of guitar, violin, ukulele, and harp. Another example is Y is a set of planets in our solar system. By Alistre method, Y is an element of Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Z is a set of vowel letters. By Alistre method, Z has an element of A, E, I, O, and U. Other types of set is the rule method. In this method, the rules for membership are indicated. It can be written in the form X such that, or set of all X such that X. For example, W is an element of 2, 3, and 4. In rule method, W is set of all X such that X is a counting number between 1 and 5. Another example, X has an element of guitar, violin, ukulele, and harp. In rule method, X is set of all X such that X is a string instrument. Another example is Y is an element of Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. In rule method, Y is a set of all X such that X is a planet of our solar system. Another example is Z is an element of A, E, I, O, and U. In rule method, Z set of all X such that X is a vowel letter. Now let's proceed to the types of set. First type of set is the finite set. A set is finite if in counting the elements of a set the counting comes to an end. For example, A has element of 5, 9, 10, and 15. B a set of days in a week. And C a set of whole numbers between 0 and 10. Other types is a finite infinite set. A set is infinite if in counting the elements of a set, thus counting never comes to an end. For example, D a set of stars in the sky, E a set of whole numbers, and F a set of all X such that X is a counting number. Other types of set is an empty set. A set without an element is called an empty set or null set and is denoted by the symbol or. For example, the set of all people in your math class who are 10 feet tall, the set of all digits that are greater than 10. Other types is a universal set. It is a set that consists of all the elements being considered in a particular problem. The universal set is represented by the symbol. For example, the set of all digits is a subset of the universal set of digits. The set of all whole numbers is a subset of the universal set of all whole numbers. Take note, the empty set or null set is the set which contains no element. The universal set is a set which has the property that all sets under consideration are subsets of it. Now let's proceed to subsets. The set X is a subset of the set Y, written as X is a subset of Y if every element of X is an element of Y. If Y is one element that is not in X, then X is called a proper subset of Y, denoted by Y is a proper subset of X. Consider the sets A and B given below. A has an element of 1, 2, 3, 4, and 5, and B has an element of 2, 4, and 5. So, B is a subset of set A, or B is a subset of A. And A is a proper subset of B, or A is a subset of B. Any set is a subset of itself, but not a proper subset. An empty set is a subset of any non-empty set. Now, let's proceed in solving the numbers of subset. To solve the number of subsets, use the formula n is equal to 2 to the power of hashtag e, where hashtag e is the number of elements in a given set. For example, list down all the subsets of the following. In A, K has an element of A, B, and C. The subset A, B, C. And first, second is the null set. Third subset is the element A. Fourth is the element B, the element C, the element AB, the element AC, and the element AC. So the number of subsets is 8. By using the formula, n is equal to 2 to the power of hashtag e, n is equal to 2 to the power of 3, and n is equal to 2 times 2 times 2, and n is equal to 8. Another example, M has an element of 1, 2, 3, and 4. The subsets has an element of 1, 2, 3, 4. Now set the element 1, the element 2, the element 3, the element 4, the element 1, 2, the element 1, 3, the element 1, 4, the element 2, 3, the element 2, 4, the element 3, 4, the element 1, 2, 3, the element 2, 3, 4, the element 1, 3, 4, and the element 1, 2, 4. By the using the formula, n is equal to 2 to the power of hashtag e, and n is equal to 2 to the power of 4, and n is equal to 2 times 2 times 2 times 2, and n is equal to 60. Now let's proceed to the equality of sets. Two sets x and y are equal, written as x is equal to y, if x is a subset of y and y is a subset of x. That is, two sets have exactly the same elements. For example, x has an element of 1, 5, and 7, and y has an element of 5, 1, and 7. Another example is x has an element of 1, 5, 5, 5, and y has an element of 1, 5. Another example is h has an element of 7, 8, and 11, and j has an element of 7 and 11. Sets h and j are not equal. Another type of sets is the equivalent set. Two sets are said to be equivalent if they contain the same number of elements. Here, the number of elements of both sets are the same, but elements may differ, and it is denoted by, for example, A has an element of x, y, and z, and B has an element of A, B, and C. So, in set A there are 3 number of elements, and in set B there are 3 number of elements. Hence, A is equivalent to B. Another example is C has an element of 1, 2, 3, 4, and 5, and D has an element of A, E, I, O, and U. N has an element of 5, and set B has an element of 5. Thus, C is equivalent to D. Now, let's proceed to disjoint sets. Two sets are disjoint if they have no common elements. For example, set X an element of 3, 6, 9, 12, and 15, and set Y has an element of 1, 5, 7, 11, and 13. Sets X and Y are disjoint sets because they have no common elements.